Guys, let's hear what Prof. Bluchnout has to say. He's got great information. Prof. Bluchnout, thank you for being here and enjoy.
Thanks, Andy. Good morning, ladies and gentlemen, and thank you for the opportunity to be here. I have to state my name has been asked. My name is James Bluchnout, and I live in Pretoria at the moment, but I'm affiliated to the Stellenbosch University, as has been introduced, the School of Public Leadership. I'm an environmental economist, and so I work on the interface between economics and the environment. And my field of specialization is on the restoration of degraded areas. And so throughout, we have started to understand and see the narrative that's developing around restoration. And restoration is such a powerful storyline, a narrative. And therefore the website, Restorative, it's been recently launched. Tell us your restoration story. We've heard this morning from Chris Square, both of them, telling us that we have to articulate the stories of restoration and communicate them. And change the narrative from one which is depressing and degrading and negative and just the earth must open up and swallow us up, to one that is positive, one that can influence the future. And restoration is that story. And restoration has got multiple dimensions, layers. We talk about ecological restoration. We're going to share some ideas today about it. We talk about the restoration of the food value chain. I'm going to share some ideas with you about that. We talk about the restoration of social capital, the culture of a community, culture of a country. We talk about the restoration of relationships. And all of that often are intertwined into a couple of projects or programs. And more than often than not, they link to agriculture. And we're going to share some ideas why that is the case. But the reverse is also true. When you've got some form of degradation, whether it is social, ecological, relationships-wise, somehow it also deals with the land. And so you see that the land has become the battlefield of a variety of different levels and a variety of different aspects within society. So when the farmer feels that he's under attack, it's because of the multiple layers in which a farmer is operating in. Social, economic, ecologically. And it all comes together. And so restore it. Tell us your restoration story. A website for farmers, by farmers, and everybody else that's involved in restoration. Grass-fed agriculture, grass-fed beef, among others. And so, this discussion today is called Heal the Land, Heal the People, and the Contribution of Cattle in it. How can we heal the land and heal the people simultaneously? And what role can cattle play in this? I'm going to take us through a couple of examples first, to set the scene, very quickly. Analyzed in a project that I'm involved with, a friend, Jaap Knot, developing a GMO-free, conservation agriculture produced maize meal, which is 80% maize, 20% soya blend. And we've looked at the variety of different prices thereof. And when we look at 14 different maize brands, we rank them, rand per kilogram. And there's a whole spread of prices, rand per kilogram wise. But the moment that you rank them in terms of kilojoule per rand, in other words, the energy that you get from it, the ranking of the maize, of the pop, changes completely. It's no longer the same. So what are we selling? Are we selling volume or are we selling nutrition? When we change that to protein per rand, the ranking changed even further. If we combine the kilojoule and the protein, which is then now our purple line, it gets all scrambled. And it's all about communication. We've heard that this morning. That what do we communicate? Do we communicate, come buy my meat, come buy my millipap, come buy my product on a volumetric basis or on a nutrition basis? What do we sell? And if we want to heal people, what do we sell them? Volume or nutrition? We have to work with scientists in developing and articulating the narratives of restoration, because we cannot just articulate and say things if it's not founded in evidence. So researchers from the University of KwaZulu-Natal did some work on this in terms of fruits. It says, this review of literature provides an overview of empirical studies comparing post-harvest quality of organically and conventionally produced fruits. The study showed that physiochemically and nutritional properties relating to the contents of vitamins and phenolics and antioxidants are higher in organically produced fruits. Same story. What do we sell? Volume or nutrition? It continues. In another study that investigated the soil organic matter relationship with nutritional quality and productivity of a variety of crops within a smallholder context in Ethiopia. And it has been found that the more the soil organic matter is linked to the manner in which it has been produced, has had massively advantageous effects on the soil, on the food quality. But there's also a feedback. Not just is it then related to the product that the people are eating, but there's a feedback also to the soils. Why can I say that? In a study that's done in America, same farmer, two fields next to one another, one he produced cover crop wheat, and the other one he produced conventional wheat. Same farmer, two fields adjacent to one another. Compared them after 2 years, and the uptake of the nutrients within the wheat is significantly different. Much higher in the ones that has been cover crop no-tilled. Why is it much higher in the ones that has cover crop no-tilled than the ones that's conventionally produced? Same land, same farmer, same climate, same soils. It's because of the feedback effect of how the plants interacted with the microbes in the soil, back from the soil to the product. And the connectedness between us as humans and the soil is food. The healthier the soil is, the healthier the food is, the healthier we will be. The biological processes in the soil and the biological processes in our guts are almost identical in terms of the work and the operation of the microbes. So are we then surprised to see these linkages? And if it applies on the crop side, on a variety of different products, then it will also apply in meat. But let's investigate. But before doing so, this question, if we sell kilograms and not nutrition, what will we get? Perhaps we will get overfed yet undernourished and impoverished population. And so the story of producing good food, sustainably produced, high quality food, is of enormous importance. It's no longer just a nice to have. It's a story about heal the land and heal the people. And we cannot make a disconnect between these two. Yes, there has been, and we have heard about it before the tea break. But it's our responsibility to break that disconnect. Not for our sake alone, but for the consumers, to heal the people. That's my beloved bull. He is no more, but he produced a lot of things for us, and I'm going to tell his story. And yes, grass-fed, by the way, just in case you've wondered. So that is the food pyramid. We all know it. We start with the decomposers in the soil, the bacteria, the fungi, the earthworms, and all the other nunus that's in the soil that even doesn't have names. And if they have, they're Latin and I can't pronounce them. Then we have, on top of that, the producers of complex compounds and carbohydrates, basically our primary, the vegetation. Then the herbivores. Then the secondary consumers, the carnivores that eats the herbivores. Then the carnivores that eats the carnivores. And then we have the apex predator. And as we go up in this value chain, in this food chain, it becomes fewer individuals with a larger footprint and an increased dependency on the previous layer. With all the energy from the sun and the water captured within the soil, and then there's a 90% loss of energy as you go from layer to layer. From all the energy that is captured in the soil, through to the producers of the carbohydrates, the plants, the vegetation, there's a 90% loss of energy. From the herbivores, 90% loss of energy. To the carnivores, 90% loss of energy. So the amount of energy that's available to us that reaches the apex predator is but a fraction of what actually goes into the soil. So if we manage that process correct and can actually enhance the energy transfer from the soil up, we can actually produce more. Because degradation, in its crudest sense, is that we are breaking the energy connection. If we want to think about regenerative agriculture, if we want to think in terms of restoration, we have to think energy flows. And how can we take the energy from the soil that's available and transfer that into the higher hierarchies? We are all mesmerized by the beauty of the biodiversity in the apex predators. Have you seen the big five? But the biodiversity in the soil is far more richer, far more complex, and far more precious for us from our survival perspective. How much care do we put into the soil? And if we can put care to the soil, how will that affect our livelihoods going up? But if you go down, there's increased complexity down this food chain, increased complexity, increased biodiversity, and many more permutations possible. And that's where beloved Rooiberg sits. He acts as the hinge between the decomposers and the carnivores and the apex animals. Herbivores are playing that important hinge. So how important is herbivores in the larger food chain? What would be the consequences if we remove the hinge, the herbivore, from the broader food chain? Will the food chain still work? Just sort of as a tongue-in-the-cheek parallel with it, there's a food chain in the economy as well, going from the decomposers being the suppliers of products, the finance, research and development, the producers, the inputs, the herbivores, the farmers. Then the carnivores being the processors, and then the carnivores that eat the carnivores in terms of the retailers and wholesalers, and then the apex predator being the consumers. It's an identical match between the two ecosystems in terms of the food chain and the agricultural value chain. And now I think it should start to emerge why the herbivore in both systems are under attack. Because of this important hinge that it plays in sustaining both systems, but therefore also the importance of communicating a restoration story. Because that's a story of healing, because it links the apex predator, the consumer, with the soil. Why? Because this is the same food chain, but just sort of packaged differently. We've got the decomposers that's linked to everything else, because everything else eventually dies and then becomes decomposed. And there's our herbivore. The big carnivores have been moved into conservation enclaves and been removed from the system. The lions are not walking in Stellenbosch streets. And the humans have moved to city enclaves. They've also been removed from the bigger system. And in the process, we have realized that glyphosate for one, but many other chemicals as well, is decimating the microbes in the soil, sterilizing the soil. And there's a report, basically I think a week or two came out very definitively that glyphosate is very strongly linked also to cancer formation. Then, currently the debate, and we've heard about it before tea as well, the attack that's on the herbivore, specifically then cattle, which I would like to submit to you is not based on science but on ideology. And you cannot fight an ideological debate with science. Science fights science, ideology fights ideology. You need the science to back it up. But ideological debate has to be confronted with on ideological terms, not on scientific terms. It will not work. You need the science, but you have to develop the ideology, and from that you need the narrative. You need to have the story. You have to have the communication. The two Chris's spoke about it so well before lunch, before tea, and I thought, they mustn't go too far because they're telling my story. They've just stopped short of it, so I'm glad I've got some story to tell as well still. And so we see with a massive disconnect between the humans and the vegetation that has happened. And this disconnect, which is the disconnect in the food value chain, consumers and the producers that we discussed before tea, is perhaps as a result also of the ecological disconnect that has happened over the last 50 to 60 years. And so now we sit with a massively broken food value chain. Because now it's about an individual commodity and not about a system. And while it is about an individual commodity, that commodity will be under attack. Because it will forget the fact that it fits within a much broader system. And when we think in terms of sustainability, affordability, nutrition, we have to think systems. And where herbivores are playing a role within the broader ecosystem. And fix that. And that will take the argument much further. So there's beloved Rooiberg. What does Rooiberg do? Or did, in his case. Because he was beauty and pleasure, but he ain't no more beauty and beauty. He became meat, money, and made babies. And many babies. But he's also a spitting lawnmower, grass regrowth on steroids through the enzymes by eating the grass. Stimulating more grass growth and more grass growth by being a spitting lawnmower. He's a soil engineer as he moves around. He's a soil fertilization by excellence. Pumping nitrogen all over the place. And he's producing a manure, a bacterial pudding for much life. By taking the herbivore out of the system, we're losing all of that. By bringing the herbivore back, and you will hear I'm talking broader than just cattle, but herbivore. Obviously the cattle being one of them. We will fix the system. We will heal the land. And by healing the land, we will start to change the narrative. I'm going to play a short video, 4-minute video. I would like to ask you to pay close attention to the narrator of this video. So I'm going to come back to what he is saying shortly after the video. And hopefully everything works.
We all know that whales eat fish and krill, and some people, certain politicians in Japan for instance, have argued that killing whales is good for human beings, as it boosts the food available for us to eat. And so you would think. But as the great whales declined, so did the numbers of fish and krill. It seems counterintuitive. Surely their numbers would rise as their major predators disappeared. But it now turns out that whales not only eat these animals, they also keep them alive. In fact, they help to sustain the entire living system of the ocean. Whales feed at depth in waters that are often pitch dark, and then they return to the surface, to the photic zone, where there's enough light for photosynthesis to happen. There they release what biologists call fecal plumes, vast outpourings of poo, poonamis. These plumes are rich in iron and nitrogen, nutrients which are often very scarce in the surface waters. And these nutrients fertilize the plant plankton that lives in the only place where plants can survive, the photic zone. Fertilizing the surface waters isn't the only thing the whales do. By plunging up and down through the water column, they also keep kicking the plankton back up into the photic zone, giving it more time to reproduce before it sinks into the abyss. Even today, though whale populations have been greatly reduced, the vertical mixing of water caused by movements of animals up and down through the column of the oceans is astonishingly roughly the same as the amount of mixing caused by all the world's wind and waves and tides. More plant plankton means more animal plankton, on which the larger creatures then feed. In other words, more whales means more fish and krill. But the story doesn't end here, because plant plankton not only feeds the animals of the sea, it also absorbs carbon dioxide from the atmosphere. When eventually it sinks to the ocean floor, it takes this carbon out of circulation down to a place where it remains for thousands of years. The more whales there are, the more plankton there is. The more plankton there is, the more carbon is drawn out of the air. When whales were at their historical populations, before great numbers of them were killed, it seems that they might have been responsible for removing tens of millions of tons of carbon from the atmosphere every year. Whales change the climate. The return of the great whales, if they're allowed to recover, could be seen as a benign form of geoengineering. It could undo some of the damage we've done, both to the living systems of the sea and to the atmosphere.
The same George Monbiot says the following: the livestock industry is trashing the living world, and free-range pasture-fed meat is the worst offender. What whales are doing to the marine system is what cattle can do on the terrestrial system, if we allow them. That's why this is not a scientific debate, but an ideological debate. Gleaning from this video, we need more, not less, cattle or herbivores to fix our soils. We need the poonamis, as he has so well articulated. Then we will have more insects, more birds. Restore the food chain, restore people and ecosystems, and cattle plays a vital restorative role in it. But that you all know that. So the question is, how do we take that further? So a little small video, short video.
So the cows are going through another move today, and this is what high density grazing is all about, multiple moves a day. With regenerative grazing, we mimic what the bison once did by building appropriately sized paddocks each day that allow us to graze hundreds of cattle across each paddock. Once the cattle have eaten some of the grass, trampled some, and fertilized the area, they are immediately moved to the next paddock and then the next. This practice produces profound results that prevent overgrazing and promote tremendous fertility and growth. If we focus first and foremost on the soil and restoring that soil function and biology, then everything else comes much easier.
So the important thing that differentiates between dirt and soil is soil organic matter, right?
Yes.
And soil organic matter is actually 50% carbon, which means if we're regenerating and rebuilding soil, we're actually putting carbon into the ground. Now, I've been told and we've read in books that it takes hundreds to thousands of years to build back soil. How quick are you doing it here?
We're able to build new soil organic matter at the rate of 0.5 to 1% annually.
Let's put some perspective on this. A 0.4% increase of soil organic matter on the world's agricultural soils would completely negate all current CO2 emissions. Alan is increasing his soil organic matter by 0.5% or 1% every year.
If we add just 1 more percent soil organic matter, that means that every single acre can hold another 25,000 gallons of water. Ready?
Go.
So we just did our water infiltration test and found that it took only 4 seconds to infiltrate the first half-inch of water. That means we're keeping our water here, right here. When you contrast that with the average farm and ranch across North America, the average water infiltration rate is less than 1/2 inch an hour. So two things are happening to that water that's sitting on top of the surface now. One is that you're going to have a percentage of it that's going to evaporate, and then the second is you're going to have a higher percentage that's actually going to run off. It's going to carry with it topsoil to the effect of 4 tons plus per acre annually. You've got a lot of nitrates and phosphates that are leaving your soil and going downstream. They're going into our rivers, into our bays, into our gulfs, into our lakes, and creating significant issues.
Adjacent to Alan's farm is a soy field that exemplifies degenerative agriculture.
This is one of the major reasons why CAFO systems are so degenerative, because this is where the feed comes from. Look at this soil. It is literally turning to dust, and we're losing probably 4 tons to 10 tons of topsoil per acre per year on this type of agriculture. We could convert this land, this vast amount of land, could be easily converted to start feeding cattle. Instead of shipping all this soy thousands of miles to those feedlots, why don't we just do it right here?
Without using any imported water, feed, fertilizer, or pesticides, Alan has increased his production 5-fold in the last 3 years.
Why are grasslands so productive? You all know that. The growth form is asymptotic. So in other words, as you are utilizing it, the biomass, the dry matter declines. But then allowed for time of rest, it recovers in a regrowth period. But then it plateaus. But that allows you to eat it again, to regrow, to allow you to eat it again. And each time it deposits the carbon in the soil. So that looks very nice, rhythmic, but obviously you need to manage it carefully on the specific land that you don't mine the resource. This is an experiment of 3,650 days, 10 years, 4 paddocks that has done exactly that. And going up and down, up and down, up and down, and each little thing which you can't see because of its density is a daily measure of the dry biomass on that specific paddock, but keeping it constant, having it available. And each time that there's regrowth, it deposits carbon in the soil, enrich the soil, and enrich then also the water infiltration capability thereof and everything else that goes with it. So I did a little bit of an exercise and asked the question, what if the colors don't work on the screen, sorry about that. What if we utilize some of the land that we have within regenerative agriculture? What's the potential of the carbon sequestration capability? We've heard from the video, Alan is sequestrating between 0.5% and 1% of soil organic matter per year on his farm. So in this example, I've said, let's work with the grasslands of South Africa and the cultivated area, and only use 30% of that area. But the soil organic carbon growth is 0.1% or 0.25% for the cultivated area, which means that we will be able to sequestrate about 70 million tons of carbon only through that, which is 12% of the the total livestock CO2 emissions is 30 million tons, 12% thereof. So if we, once you convert it from carbon to CO2, then it is 12%. In other words, what that is saying is if we use 30% of our rangelands, of our savanna and of our cultivated area, and it only grows soil organic carbon by 0.1%, then we can sequestrate so much carbon, almost 70 million tons. And all the methane emissions from all the animals in South Africa is about 12% thereof. It's not a scientific debate. It's an ideological debate. And if you convert this carbon sequestration potential into rands, it's 8 billion rands worth of carbon sequestration that sits there. If we change it and we say, let's use 50% of our land area, and we up the sequestration capability to 0.25% for the grasslands and savanna and 0.5% for our cultivated areas, then we talk about a 31 billion rand worth of carbon that sits there. And suddenly all the methane emissions of all the animals are about 3% of what can be sequestered by our grasslands. And if we up it even further to 70% of our grasslands and our cultivated areas, and we say we put 0.5% growth into grasslands and savanna and 0.75% into the cultivated areas, then it's 80 billion rands worth of carbon dioxide a year. If you compare that to the GDP of agriculture, which is 74 billion rand, the carbon sequestration capability of the rangelands are more than the GDP of agriculture. I find that astounding. But now, the CO2, the methane emissions from all the animals are about 1.2% of the carbon sequestration capability of our grasslands and of our savanna. So how can that be done? There, we've heard, is Danny Slabbert's farm. Chris spoke much about him before tea. It looks like a tapestry, a piece of art. If you look at his Drakensbergers there, using the strip grazing on natural fat. But you say it can't happen in drier areas. This is D.F. Pfeiffer's farm. He in the northwest, and he has maximized the utilization of his resource because he wanted to suppress the weeds. But he's actually controlling towards this. And this video has been taken in the heat in the middle of winter. And this is then PJ Barnol's. That specific day when that has been taken, it was -6 degrees Celsius. That's why I no longer live in the southern Free State, but moved from there. I've had enough of cold. I know what that means. And then Eckhard Benecke. Two different systems that he applies. The first system is his weaners. Happily munching on pasture, as you can see, in the middle of winter. Happily munching away, stretching all the way to the horizon. But that is the weaners. On this side, it is his herd. on the normal grasslands. And he is managing towards a mat where there's absolutely no spot for weeds to come, no chances of erosion, but building up a herbaceous layer, a layer filled with P&P, poo and P, to activate the soil, give it a very good strong doses of P&P in order to manage the land, heal the land, and produce solid food. So the question is, but does it work? So we've done some work in terms of, in this case then ultra high density grazing, but compared to conventional systems. Area hectares per large stock unit on the one axis, and then the effectivity or the productivity, thereof on the other axis. Kilogram of meat at market age per hectare. The conventional system in the blue dots that you can see, sort of in a band between 5 hectares per large stock area, large stock unit to about 12.5, producing between 10 and 20 kilograms of protein, of live weight per hectare. We add the Namibian case a variety of different ox-based systems, very much similar also that you can say to non-feedlot systems, keeping them for much longer, much drier environments obviously, so using much more hectare space. And so we can ask the question, but that does mean, are we trapped between 10 and 25 kilograms per hectare? And the answer is no. The green dots are some of the farmers that I've shown the videos of. The ones here at the bottom have just started it a year or two ago. The others, which is on the left top, have been doing it for more than 10 years. 1.8 hectares per large stock unit, producing 80 kilograms of produce of protein per hectare. In the process, increase the numbers of animals, increases grass and species diversity. There is a 24-fold difference in the production capability of the conventional system compared to this system. That is also healing the land. And so we return to the question that I've asked initially. Access to affordable, sustainably produced, nutritious food. So there is much more that the land can produce, and Chris has shown the statement of Adcock that says much of our land has been what? Understocked and overgrazed. And we can see it here. That statement that's been made so many years ago is actually now founded in the evidence that we have. But then we have to think systems and heal that land. Heal the land through restorative work, yeah. So, if we can produce so much utilizing grass, which is a free resource, will the meat become more affordable or not? It must. It must become more affordable. Will it become more sustainable? It must be more sustainable. Will it be more nutritious? Well, Peter's just here in front of me, so I need to be careful what I'm going to say, because he has had that presentation with what Arno Hugo said. So, but the answer is yes. I'm not going to read all of this from Mohilisa's PhD thesis. But what he did with Professor Hugo, who did the very same test that Peter spoke of, comparing the benefits of the two different grass-fed and grain-fed animals, with the grass-fed being far superior in many instances. Much of it is linked to the fact that we're now talking about AB grade or B grade compared to A grade. So much involved because it is older animals, because of the natural process that's involved from growing from an A grade to a B grade or then a B grade. But we've heard the question earlier this morning, what is on the consumer's table? Is he buying that meat that is on his table? Is he going to ask all the different questions in terms of where it comes from? Is it A grade? Is it AB grade? Is it B grade? No, he's eating the meat that's on his table. So it is our responsibility to make sure that we communicate it well, that yes, it is slightly matured, it is older, it's a B grade, perhaps. But what's the advantage thereof when you eat it? And so, in summary, with respect to the nutrition part, is that the total SFA, fatty acids, is lower in grass-fed meat. It is very low in the cholesterol-raising fatty acids. It's very good in the omega-3, and it's very good in omega-9. So, in summary, when we look at it as a package, to conserve and protect the entire food chain is important, not an individual species, a layer that you take out. Consider the vital role of herbivores in this larger ecosystem. Promote grassland productivity to mitigate and adapt to climate change. Integrate crop production, animal husbandry and grass-fed animals, as it has been mentioned also earlier, in terms of regenerative ways, through and that many farmers are already doing. And consider cover crops and pastures as a form of feedlot. As we have seen in some of the videos that I've shown, it is actually a form of a feedlot. And shorten the production value chain by linking the producer with the consumers. Because today's visionary will be tomorrow's outlier, but it will be next week's norm. And I can see how this momentum that has been created also through the Grassfed Association, where it might be considered today's visionary. Tomorrow it will be the outlier. Perhaps, hopefully, it will be next week's norm. As we've seen from some of those green bullets that I've seen. They were considered crazy 10 years ago when they started. But look at what they're achieving. So yes, indeed, heal the land, heal the people, and cattle can help and play a major role in that. But we have to tell the story, and tell the story appropriately, because restoration requires a restoration culture, and that requires a storyline. And I think through this initiative, and through what is happening, and through the collaboration, Adrian, Peter, everybody here, Chris Squared, the story is developing, a new narrative is developing. And we have to pitch it so that we can see how animals, herbivores, cattle, can play a restorative role in society. Not just of the land, not just of the economy, not just of your farm, but restorative in a broader sense as well, of healing a culture, healing people, bringing people together. Chris has made some excellent suggestions in terms of how it can be done, because this system, introducing this type of operation within a communal areas and linking communal farmers with commercial farmers, taking it forward, should not be that difficult. Thank you very much, Adrian.